Okay, I think it's time to start. Hello, everybody. I hope you're all having a good weekend so far, and welcome back to another ACSL lesson. Today, we'll be going over two very basic but very useful uh, data structures, stack and queue. So, um, first, let's go over what stack is. Stack is just like it's similar to a list, but it follows a last in, first out type operations, and it has like three main operations: push, which adds an item to the top of the stack, and that hides any items already on the stack; pop, which removes the newest item in the stack and returns the value. And if the stack is empty, it returns a special value called nil. And peek, all it does is like pop, it just returns the top element without removing it. So you can think of this as kind of like a stack of pancakes. You can add pancakes onto the top, or you can eat, the top pancake of the stack, but you cannot access the pancakes beneath it, right? And stack is pretty simple, but it's used in a lot of like recursive type algorithms, and you'll be seeing it a lot. So let's go over a quick example of um, how to use stack with these operations. So first we have push. So we start with an empty stack, and when we push P, we just get 1P, right? And then if we pop it, we remove it, and then we're left with an empty stack again. So then we can push more items like, let's say, D, Y, and R. You can see that they just get added onto the end. Sorry, give me a second. Get added onto the end each time. And if we pop again, it's only the end element that gets removed. So we can't remove these first two unless we remove R. So we push again, pop, pop, and we push. Finally, we're just left with these two letters. Does anyone have any questions? Okay, that's great. Next, we have a queue. So queue is like stack, but instead of first in, last out, it goes in a first in, first out type order. So queue also has three main operations: push, pop, and peek, or you can sometimes see push and pop called NQ and DQ. So push just adds an item onto the end of the queue. Pretty simple. Pop removes the frontmost or oldest item in the queue and returns it. And sorry, this isn't written here, but if there's nothing in the queue, then it returns a special value of nil. And then finally peek just returns the frontmost element without removing it. And a great analogy for this would be a line. So when you push something into the queue, you're just getting in at the end of the line. And when you pop something or DQ it, that's the first person in the line just leaving. And queue also has its own uses. I think the most like well famous would be something like depth first search. If you're if you know if you're familiar with graph problems, you'll have to do a lot of like searching through them. And one main tactic you can use. So if we have a graph here with nodes like so, they're all connected. So let's say you start over here and you want to find a specific node, let's say here. And depth first search is an algorithm where you look at every single node connected to this current node, and then you add those nodes to a queue, right? So let's say this is, well, let's number them first. 1, 2, 3. 4, 5, 6. So if we start at 2, and then let's look at each of these nodes. So we add 1 to our queue, 3 to our queue, and 5 to our queue. And then instead of simply like going to the next one, we look at the first node in our queue. And that allows us to, and then we go to that node, and then we look at every node connected to that one. So then we would have 4. And 4 is our target destination, but wait, well, so why would we want to use a queue for depth first search? Well, this way, instead of having to travel down each branch of a node individually, if we don't find what we're looking for, we can instead just go back to a higher level in the queue. And then that way we can immediately start looking for um, looking at other nodes in the graph. And this is used in like especially map services like Google Maps. If when you choose to, when it tells you to go somewhere, it finds that path using like breadth first search. And a quick example of how a queue works. As before, you start with an empty queue, and you just push I in, you push O into the end, push Y. And then now when you pop something, instead of taking it from here, you take it from the beginning. And since I is the oldest frontmost element, and when you push T, push it to the end, you still push it to the end. But once again, you're popping from the front this time. So after all this, you're left with OO. So now you guys know what queues and stacks are. I want you guys to try this ACSL problem by yourself. And then when you have your own answer, please type in the chat. Okay, so now that you guys have had a chance to try for himself, let's go over this together. So we're starting with an empty stack. Let's draw a stack here, and we push T onto it. So we have T, we push H like so, E, K, and then now we pop. So when we pop, it's a stack. So we take it from the top of the stack, and that would be K. We just remove it. And then we pop another one, E, so let's just move that. And then we push I. So I, N, and then we pop again. I'll just cross it out this time. Push G, push A, push N, and then we pop twice, or three times, sorry. So cross out these three from the top. We push D, we push I, and we pop, and we pop. Okay, so in the end, we have TH and I is on the top of our stack. So after another pop, I will be the one that's returned. And this is the simplest way to, solve a stack problem. But if you, it's just like writing it down on paper and then crossing out the ones that are popped. And then in the end, you just look at the topmost element that still exists. However, there is a faster way, which I'll show you, where you can just look at the end. So you'll notice that if it ends with a pop statement, that means that the first, the last push statement that we see has already been popped away in the stack. So that cannot be the answer to the problem, right? And so we see here we have a pop. So that means this push, it basically doesn't exist. And then we have a pop here. So this push doesn't exist basically. And these three pops together just remove these three pushes. This pop removes this push. And then in the end, we have this push by itself without a pop after it. So that means that this push will be the topmost letter remaining after everything else. Or if you want to do like more step-by-step way without having to look back and forth, you can just think of the number of, say the number of letters you have while going through the stack backwards. So if you see a pop, then or start from 0 over here. And if you see a pop, you subtract 1. So we go -1. See another pop, go -2. And we see a push, so we add a letter. So -1. We see a push, so we go 0, but then we go pop 3 times again. So I'll just skip here to -3. We push, so we go -2. We push, so we go -1. And then this brings us to 0, but then we pop again, so -1. And we push to 0. And then here we finally get our first positive number, 1. And when we get to 1, that means that we have the letter that's going to be on the top after everything is done. You can just push everything and then count the number of pops and cross out the number of pops on the list. Okay, so that sounds like it would work, but actually, thing is, sometimes you end up you can have a situation where, let's see, if you can, how do I explain this? You can end up popping some things, and then once you push, well, yeah, so you can pop things in the middle. So okay, let's do your strategy first. Push everything and then pop the number of pops. So T, H, E, oh, sorry, I'll do it this way. T, H, E, K, I, N, G, A, N, D I. Okay, and then how many pops are there? We have one, two, three, four, five, six, seven, eight. One, two, three, four, five, six, seven, eight. So you can see that if we just push everything first and then pop everything, we end up with a different letter than what we were supposed to get. And the reason why that happens is because if you do it in the order that it gives you, what ends up happening is E and K are actually removed before I gets put in. So then you have THI at the beginning, right? And then if you pop everything else, like at the end, you have I in the position where E was originally. Do you understand what I'm saying? Okay. Does anyone else have any questions? What about the pop part do you need help on? Okay, so sorry, should I explain this better? So let's go back to our pancake analogy. So a stack is just like a stack of pancakes, and all the elements are a pancake in the stack, and pushing just adds a pancake on top of the stack. And popping, all it does is return the like tallest pancake on the stack. So it can't remove any other pancake, only the top one. Does it make sense? It just removes the top one and then, yeah, okay, that's great. All right, next problem. Oh, yeah, and the answer was I. Nice. So this one's a lot longer, but you can just follow the same steps, either writing it out on paper and then crossing it as you go, or doing the counting method. Okay, let's go over this problem together now. And I'll go over both methods first. So I'll reveal the answer first so we know what we're looking for. And it was E. Good job, everybody. Let's see. So drawing it out first, we have F-O-R, and then we pop, push T, I, and pop, E, T, pop, H, A, N, pop, N, and we pop twice. So push I, push V, push E, push R, and then pop again, push S, and then pop twice. We push A, push R, push Y, pop twice again, and then we pop, oh yeah, pop 3 more times. So 1, 2, oh, whoops, I missed this A here. 1, 2, and 3. So then E is the last letter or the topmost letter remaining in the stack. And that is our answer. And now let's do this the kind of the counting way, the fast way. So starting from the end, we start with 0 and then pop brings us to -1, -2, -3, -4, -5, push, -4, -3, -2, and we pop 2 more times, so -4. We push, so -3, -4, -5, push, so -4, -3, -2, -1, but we pop 2 more times, so we go back to -3, push, -2, -3, -2, -1, 0, -1, and 0, and then we finally get to 1 over here at push E, which is our answer. Yes, so ACSL uses a syntax for pop where I think this is old syntax, where you put the name of the variable that you're storing the data in. So if you pop let's look at our first pop. So if we had 4 FOR, we just pop it, and then we'd store in a variable called X. But yeah, but I think now they just directly say X is equal to pop now, which to be honest, it makes a lot more sense. Or I'm not familiar with assembly, but in normal code, it would just be X equals pop. So I think that's why they switched. But yeah, that's all that means. X is just the name of the variable that they're storing the popped item in. So does anyone have any questions about either method, the counting or the writing out? Okay, just feel free to ask questions at any time. Let's move on. Oh, oops. Okay, you didn't see that. This is another stack question. And yeah, once again, feel free to type your answer in chat. And sorry, this isn't very clear, but this push E is also part of the instructions. So try not to miss that one. So it looks like a lot of people had the chance to answer. Let's go over this together now. And I'm just going to start with writing it out again. So we push E, B, E, N, pop, 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 E, Z, E, R, pop and pop, S, C, pop and pop, pop again, push R, O, O, and we pop 3 times. We push G, E, and then we pop and we pop. So then our first letter is E. And then let's do the counting method now. If you haven't been using this way, I recommend you like count with me. So once again, we just start with 0, and if we see a pop, we subtract 1, and if we see a push, we add 1. And then when we get to +1, we stop. So pop, -1, -2, -1, 0, -1, -2, -3, -2, -1, 0, -1, -2, -3, -2, -1, 0. Oh, sorry, -2, -3, and -2, -1, 0, and then this is +1. And this is our E, which is our answer. What about the E at the start? So with this E, once we push it, it gets immediately popped by this next one. So that's why it's not the answer. Yeah, so that's why we're counting. So what we're really doing is when we're going -1, we're just canceling out the next push that comes after. So that way, when we finally get a push that's like, when we finally get to +1, it's a push that's not immediately canceled out by the pops afterwards. The E that got popped is this E over here. This one I circled over here, E. The answer is the first E. Well, yeah, it would just, when the ACSL asks you what letter gets popped, it'll just give you a set of answer choices, A, B, like C and D, and they'll just have different letters. So, and like N, B, E, or F or whatever. So you don't have to point out exactly which one got popped. You just have to be able to give the letter. And it doesn't really matter which one that got popped, because these could also all be completely different letters. And you just have to follow the same algorithm to get to this push command. Okay. Yes, the answer was E. Let's move on. Here we are seeing the near notation where we have X equals pop instead of pop X. And it's the same thing as before. It's just popping the topmost element. think you guys are getting faster than at this. Good job. So let's look. Correct answer was A. So strength empty stack, push C, A, N, pop, pop, push I, no, pop, S, M, and we pop and pop, push A, J, and pop, we push O, pop, R, and pop. And then A is our last letter. And then I'll just quickly go over the counting method. This is -1, 0, -1, 0, -1, 0. And then this is +1. And this push command doesn't get canceled out. So A is the answer. Yes. Oh, so one more trick I should probably mention. When you guys are taking the ACSL on your computer, if you don't want to write out the things, you can also just really easily type out things. So let me see if I can find a text box. So I think typing will probably be faster than writing for some of you. So what you can do is you can just easily type CAN. If you pop, you just backspace, and it'll be the same thing as writing it out, except you don't have to scribble everywhere. So if you're not using the pop method, you can also use your keyboard to type somewhere. Anyway, let's go to the next problem. Okay, so now, watch out. We're not doing a stack anymore. We're doing a queue. So now, make sure to be popping from the beginning of the queue instead of from the end, like the stack. Yeah, so when we add and subtract, when we're counting it, we just start with 0. And if the first one is popped, then we go -1. But we can't use the counting solution on queues. Queues, they pop from the beginning. So here you can just write it out. Okay, I think a lot of people have already answered. So let's go over this ourselves. Let's go over it together. Sorry. So now let's start by running it out. We push M like usual, push A to the end as usual, D, and then now we get our first pop. So we're not popping D like before with a stack. We pop the first element, which is M. So we take that out like this. And then we push A, we push M, then we pop A, we pop again, and we push E, push D, pop and pop. Oh, wait, one more pop. Push F, push A, push R, pop, push G, pop, 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 push E, and then we pop. And then E is the only remaining thing to queue, and it will be the next popped element. So I remember earlier, Catherine mentioned something about counting the total amount of pops and taking that from the end. And while that doesn't work with stack because you can end up taking elements in between, this will actually work the queue because it will always be taken out in the order that you put it in. So there is a shortcut for this as well. So let's see. If we count the number of pops, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. 11 pops, unless I missed any. And then now all we have to do is count forward the pushes until count forward 11 pushes, and then the one after that will be our answer. So we start with M. This is 1. This is 2. This is 3, 4, 5, 6, 7, 8, 9, 10, 11. The next one is E. So yes, Catherine, your method is actually pretty smart, but it only works with Q. So does anyone have any questions? Okay, if not, let's move on to the next problem. And yeah, the answer was E. This is another Q one. It's a lot shorter though. So just try to answer this one as fast as possible. Okay, let's look at the answer. It is R. Good job, guys. Yeah. So let's just do the counting method, which is way faster. X equals pop. So there's 1, there's 2, there's 3, and there's 4. So now we just count through the pushes, which is 1, 2, 3, 4, and the next one is R. Yep. And if I guess we can go over the written way too. So if you're ever unsure about the counting method, you can always just write it out and simulate through the pushes and pops. It's better to, take a little bit of extra time to get the point right than to completely miss it, because, it is this is like one of 5 points you're going to get in the test. So we have A, Q, U, we pop A, push another A, R, pop, pop, push I, and we pop, we push U, push S, and R is the next element that will be popped. Okay, next problem. And now we're back to stack. So remember, we're popping the newest element now. Last in, first out. Okay, I think let's go over the answer. It is L. Good job, everyone. Yes, so we're back to stack, so we can use the counting method again. So starting with X, we have -1, -2, -1, -2, -1, 0, -1, 0, and then we push to +1, and this push command is the one that's not canceled out, so it's O. Yes. And does anyone need me to show the written out version, or if not, let's just move on. Okay, this is another Q problem. So make sure you're popping from the right place. Okay, so let's look at the answer. And it is L. And I think everyone got that correctly. So Q, we'll just count the pops. As usual, pop 1, 2, 3, 4, 5, 6. So 6 pops. And then we go 1, 2, 3, 4, 5, 6. And our next push is L. So L is our answer. Let's go on to the next problem. Okay, so now when we now this is another stack problem, but ACSL added another extra constraint onto the problem, which is no letter is pushed onto the stack if it's identical to the top of the stack. What will the next popped item be? So now our method before of counting the pops doesn't really work. So the best way to approach this would be just simulate it out and write it out. Okay, let's go over this problem together now. No, oh wait. So we have to keep in mind that no letter is pushed onto the stack if it's identical to the top of the stack. Right. So let's just start. We push A, we push T, and then now it tells us to push T. But the problem says if it's identical to the top, we can't push it. T is T. So we'll just ignore this one. And we pop now. And this is a stack, so we take the top off, which is T. We push A. Oh, but wait. A is now the top of our stack. So we can't push A onto the stack anymore. And then we push C. We push K. We pop 2. So just take out these 2. We push O. We push F. We push T. We pop it. We push H, E, and here's telling us to push another E, but we can't do that. So let's move on to M, P, or P. Oops. And we pop out these 2. We push an I, R, we pop twice, and we tells us to push another E, but can't do that. So we just ignore it. And finally tells us to pop twice. So we take out this and we take out this. So it's F. And I think most of you guys got that one. Just make sure. And oh, ignore that. That should say F, right? So just make sure in the competition you're reading through the problem carefully. Yeah, make sure you read the problem carefully because even though most of the time it's going to be a simple push pop, sometimes they throw a curveball condition in there. So make sure you keep you follow the rules that they're giving you and don't rush. So clear all. And this is our last practice problem today. And it's just a simple Q problem. Okay, let's go over this problem together now. And since it's just a normal Q problem, there's no special conditions. We'll just do our counting method. So this is 1 pop, 2, 3, 4, 5, 6, 7. And yeah, so we just count ahead from here. That's 1, 2, 3, 4, 5, 6, 7. So, and the next push is D, which is our answer. And let me check. Yes. So, does anyone have any final questions for how any of this works? All right. If there are no questions, that will be the end of today's class. And before you guys go, I do want to mention that Rich Code now has our own blog. And on our blog, we'll be posting mostly tutorials, for coding like Python, Java, and stuff. And right now we have a few blogs, a few blog articles of our own. But if you want to write your own article, you can always submit it to us with the link that link here in the chat. It can be anything coding related, coding like math, even programming, CS, STEM. So if you guys are interested in that, make sure to send an article our way and we'll look over it and put it on our website. So please save this link somewhere safe in case you want to submit an article in the future. And other than that, that will be it for today. Thank you guys for coming. See you guys next time.
Bye.
Bye.
Bye.